sky, gazing far.
Hello guys, I am Rajdeep and welcome to my channel Study SUCCOUR. Today we will discuss about nanoscience and nanotechnology. But before that we should know about nanomaterials and its various examples like nanoparticles, nanocrystalline materials, carbon nanotubes which are commonly known as CNTs, nanosilicates and lastly ferrofluids. So let's begin. Nanomaterials and their various examples. Nanomaterials are constituted of several tens or hundreds of atoms or molecules and can have a variety of sizes and morphologies. Morphologies like amorphous, crystalline, spherical, etc. Particles with size between 1 to 100 nanometer are normally regarded as nanomaterials because the average size of an atom is in the order of 1 to 2 angstroms in radius, and we also know that 1 nanometer equal to 100 angstroms. So in a particle of radius 1 nanometer there may be 3 to 5 atoms present. Now, do not confuse nanomaterials with bulk materials. The two principal factors that cause the properties of nanomaterials to differ significantly from bulk materials are increased relative surface area and quantum effects. These factors can change or enhance properties such as reactivity, strength, and electrical characteristics. About bulk materials we may discuss later on another video. So let's continue with nanomaterials. Some nanomaterials are already commercially available in form of dry powders or liquid dispersions. Liquid dispersions are obtained by combining nanomaterials with an aqueous or organic liquid to form a suspension or paste. Now, chemical additives like surfactants or dispersants can be necessary to obtain a uniform and stable dispersion. The nanomaterials constitute a wide range of materials, including nanocrystalline materials, nanocomposites, nanoparticles, carbon nanotubes, and quantum dots. They all have microstructural features on the nanoscale. This is the common link between all the nanomaterials. Now let's discuss about some nanomaterials. Nanoparticles. Nanoparticles or nanocrystals are made of metals, semiconductors or oxides are of interest for their mechanical, electrical, magnetic, optical, chemical and other properties. Nanoparticles have been used as quantum dots and as a chemical catalyst. Nanoparticles are usually defined as a particle of matter that is between 1 and 100 nanometers in diameter. These are of great scientific knowledge because they are a bridge between bulk materials and atomic or molecular structures. Nanoparticles have a very high surface area to volume ratio. This provides a tremendous driving force for diffusion, especially at elevated temperatures. Nanocrystalline materials. Perfectly crystalline materials rarely exist in nature. The presence of defects in nanocrystalline materials lead to their interesting properties. In perfectly crystalline materials, atoms are all periodically arranged, whereas in amorphous materials, atoms are disordered. Most materials, however, are somewhere between these two extremes. Nanocrystalline materials can be engineered by increasing the defect density in a material to point where the grain size approaches the nanoscale, which is less than 100 nanometers. Carbon nanotubes. Carbon nanotubes or CNTs are similar to a sheet of graphite rolled into a tube with each end capped by half of a fullerene, that is buckyball, or which is also commonly known as C60, and they can be either single walled or multi walled. CNTs are known to be stronger than steel, and yet they are highly elastic under load. There are many applications of carbon nanotubes, like they are used as light fibers for bulletproof vests, field effect transistors, tips for scanning, electron microscope, and also as space elevator. Some futurists and even some scientists and engineers have proposed that CNTs can be woven into a long, thick cable with one end anchored on an ocean platform and the other end in space. The so-called space elevator would slowly hoist heavy loads into space, bypassing the need for rockets. While most serious scientists still consider this idea a dream, it serves to show the boundless possibilities of carbon nanotubes. Nanosilicates. Nanosilicates or clays are layered materials where the building blocks are typically platelets of 1 nanometer thickness. These particles may be charged and have ions loosely attached to their surface. As a result, assemblies of such particles can organize into a variety of structures that show drastically different properties depending on external forces or applied electric fields. With the increasing availability of clean chemistry customized synthetic clays, there is presently a growing scientific activity associated with clay materials. This image shows the surface of a synthetic clay particle by means of an atomic force microscope. Ferrofluid. A ferrofluid or ferromagnetic fluid is a liquid that becomes strongly magnetized in presence of a magnetic field. Now, as discussed earlier in this video during the introduction of nanomaterials, I told that liquid dispersions are obtained by combining nanomaterials with aqueous or organic liquid to form a suspension or paste. So ferrofluid is an example of such liquid dispersions. It is a colloidal liquid dispersion made of nanoscale ferromagnetic or ferrimagnetic materials suspended in an organic solvent. Much of their usefulness is related to the effect that the liquid stiffens when it is exposed to a magnetic field. In strong magnetic fields, the ferrofluid may look like jelly or rubber, and thus can be used to reduce vibrations. This image shows the pattern ferrofluid forms with a magnetic field underneath. Nanoscience and nanotechnologies involve studying and working with matter on an ultra-small scale. 1 nanometer is 1 millionth of a millimeter, and a single human hair is around 80,000 nanometer in width. The sheet of paper is about 100,000 nanometer thick. The technology stretches across the whole spectrum of science, touching medicine, physics, engineering, and chemistry. Nanotechnology is not just about dimensions, but the control of novel properties of materials that are the result of nanoscale dimensions. Properties of materials change at the nanoscale. An innovative and inexpensive way of making nanomaterials on a large scale has resulted in novel forms of advanced materials that pave the way for exceptional and unexpected optical properties. So guys, that's all for today. If you have any queries, then you can ask me through my Insta account, StudySuccor and Rajdeep_Das. And today I have a news for you that StudySuccor is providing online interactive classes during this COVID-19 pandemic to students of JEXPO Physics and Chemistry, classes 9 and 10 CBSE Board Physics, Chemistry and Biology, and for classes 6 to 8 any board Physics, Chemistry and Biology, with a free demo class. For more details, contact on the number given. And yes, do like, share and subscribe my channel StudySuccor, and also press the bell icon. Thank you.